Hello, sixth graders. Hey, what we're going to do today in this lesson is about air pressure. We're surrounded by this atmosphere, all these air molecules, and they're bumping up against us, and we don't normally even notice it at all. But there's actually a lot of energy in the air pressure, a lot of pressure, because the atmosphere is pushing down on us and squeezing. Okay, so anyway, here it comes. Let's get your notebook ready. Have your notebook set. Get yourself a piece of paper, and let's go. All right, you should have your assignment sheet right now, and you should also have a piece of paper. Get it ready if you don't have one already. And the assignment today is going to be air pressure. So everybody write that down on your assignment sheet number 28. Title your paper, air pressure. Okay. And off we go. Get a piece of paper. So it's gravity that's pulling the air and holding the air to the Earth's surface, and it's gravity that's pulling it down and pressing it together. Make sure you've written this down. Air pressure is caused by the weight of the atmosphere pushing down, squeezing the air molecules together. If you need more time, pause it and then move on. Here's an interesting fun fact. A lot of people think the air doesn't weigh anything. Well, actually it does. If you get the entire atmosphere, if you could find a way to weigh it, it's about 5.5 quadrillion tons. Now this is called the atmospheric column. What this sort of picture is, down here, edge on, you can see the troposphere is down here where the weather is. Then you have the stratosphere, mesosphere, thermosphere. Anyway, so the further you go up, the less air you have, because the air molecules, you have fewer of them squeezing them together. So this is where most all the air is. But you still have some stray floating around molecules out here in the exosphere where the satellites go. Okay? So write this down now. When air compresses, its density increases. That means when it compresses, when it's pressed together, you have more molecules of air in a given space, so its density goes up. More air molecules are crammed into a given space, and its pressure increases. That means that it's pressing outward harder because they're getting pressed together further. They're all moving around and stuff. Okay, so more air molecules are pushing into bumping into surfaces, okay? So now we're going to draw kind of a little diagram about that. All right, so the density increases. Remember, density, the formula for density is D equals M over V. We already did that, right? Density equals mass divided by volume. This is how much stuff you have in a given space. That tells you what the density is, right? So when you squeeze it together, the air pressure, when you press it together, let's say you have a little container. Okay, box. And this box has air in it, and the air molecules are sort of spaced out evenly. And the air pressure, what it amounts to is, since they're flying around and bumping into each other, they're also bumping into the inside surface of the box, and that's the outward air pressure, right? Okay, now to compress the air pressure is more compressed. It raises the air pressure. Let's say you have like a plunger kind of thing, right? So here's a plunger, like a syringe or something. And it's pushing down with a certain amount of force, right? And what's going to happen then, these air molecules are still going to be in here, but they're going to be in a smaller space. They're going to be crammed together more tightly. And so now what we're going to draw is the air molecules, but drawn closer together. Okay? It would be the same amount of air, the same weight of air, same mass of air, but it's in a smaller volume, so it's more dense. So we have a greater density here when they're more compressed like that. So here's what happens then in the atmosphere. What's going on is, if you have the whole weight of the atmosphere pressing down, if you're high in altitude, you only have a little bit of it pressing down. So they aren't being squeezed together very, very hard with not much pressure. So there's hardly any air pressure up here, and you got a fair amount of distance between them, and the density's lower because you have fewer in a given volume. But the further down you go towards sea level, the more they're getting squeezed together, okay? And so you have more in a given volume, the density's going up, and same down here. The harder they're getting squeezed together because you have all this air squeezing down, pushing down the weight of it, compressing it, and so the density will increase and the air pressure increases as you go down in altitude, and it decreases as you go up in altitude.